All right, everyone, welcome back. We're diving deep today, getting into the nuts and bolts of something pretty crucial in the data science world.
Definitely crucial. Absolutely.
We're talking NumPy. And to guide our deep dive, we've got this source right here, Mastering NumPy for Data Science. This deep dive, we're going to try to, really unpack why it's considered like the bedrock of data science in Python.
It really is.
So we'll be exploring NumPy arrays, how they work, their efficiency, even real-world applications like image processing. And to top it off, we'll tackle a few common interview questions that often pop up around NumPy, just to, give you a little edge.
That's a great idea.
So yeah, let's get right into it. Okay, starting with the big question, what is NumPy, and why is it such a big deal in data science?
Well, you see, NumPy is it's kind of like the fundamental package for scientific computing in Python. Data science often deals with like huge data sets and a lot of complex calculations. And NumPy provides these things called arrays, which are essentially, you can think of them like lists on steroids, but designed to handle these kinds of numerical data way more efficiently than standard Python lists.
Okay, so when you say more efficient, what do you mean? Like, what makes them so much faster or better?
It's the way NumPy is designed,
Oh, yeah.
It's built with this focus on speed and efficiency for numerical operations. Like, think about training a machine learning model on a data set with like millions of data points. Without NumPy's optimized operations, that process could take, I don't know, days. But with NumPy, it's streamlined.
Ah, I see. So it's all about handling those massive data sets and doing complex calculations without, like, your computer exploding.
Exactly.
Got it. So before we get too deep into the weeds, let's take a step back. For someone who's completely new to this, how do you actually get NumPy set up and ready to use?
Oh, it's pretty straightforward, actually. You can install NumPy using pip. You just type pip install NumPy in your terminal. And then to actually use it in your Python script, all you got to do is import it using import NumPy as NP.
Okay, important NumPy is MP. Got it. So
Yeah.
that MP is like the standard shorthand you see everywhere, right?
Yeah, exactly. It's like the nickname everyone uses. Saves you a few keystrokes every time.
Okay, perfect. So we got NumPy installed. It's ready to go. What can we actually do with it? What are some of its superpowers, so to speak?
Well, at the very core of NumPy, you have the np.array. This is what lets you create these powerful NumPy arrays from lists or other data structures.
Right, the arrays we were talking about earlier. But NumPy is not just about creating these arrays, is it? There's a lot more you can do once you have them, right?
Oh, absolutely. You can do a ton. Like you can index, slice, and reshape them. This gives you like this fine-grained control over your data, like you can grab specific elements, sections, even change the entire structure of the array if you need to.
I see. So we can really slice and dice and rearrange the data within these arrays however we want. But I'm still curious about something you touched on earlier, how NumPy can perform calculations on entire arrays at once. What's that all about?
Ah, that's where the real magic happens. It's all about something called broadcasting and vectorization. Basically, instead of looping through each element in an array one by one, which can be really slow, NumPy can apply operations to the entire array simultaneously.
So it's like doing a ton of calculations all at the same time.
Exactly. Imagine like trying to add two lists of a million numbers. If you did that element by element, it would take forever. But NumPy can essentially do that addition for the whole lists at once, which is way faster, especially in data science where you're dealing with, massive data sets all the time.
I see. That makes a lot of sense. It's like
Right.
instead of adding 1 plus 1 plus 1 a million times, it just knows to add a million to a million.
Exactly. And that's what makes it so powerful for the kinds of computations we do in data science.
So, you mentioned all these computations. It sounds like NumPy also comes with a whole toolkit for things like statistical analysis and even linear algebra, right?
Absolutely.
Hmm.
It has built-in functions for all the common statistical stuff, like calculating the mean, median, standard deviation, and it does it all super fast because, well, it's NumPy. And for linear algebra, oh man, it's got you covered, like np.d.t for matrix multiplication, np.linealogy.nv for finding inverses, all that good stuff.
Wow, it sounds like it's a one-stop shop for all the heavy lifting you need to do in data science.
It pretty much is.
And speaking of heavy lifting, you mentioned matrix multiplication there. That really reminds me of how crucial NumPy is for machine learning. Could you tell us a bit more about how it plays into that?
Oh, yeah, for sure. Machine learning algorithms, they like rely heavily on linear algebra and matrix operations. And NumPy provides the foundation for handling those operations efficiently. Think about working with images, for example. Each image can be represented as a huge array of pixel values. And NumPy lets you manipulate and analyze those arrays like it's nothing, making it essential for computer vision tasks.
That's fascinating. So it's not just crunching numbers, it's actually dealing with images and all this complex data in machine learning.
Exactly. And that's just one example, really. NumPy's reach extends to so many different areas.
Wow, it's like the unsung hero of all these cool cutting-edge applications.
Hmm.
It seems like knowing NumPy is almost like a prerequisite for anyone who wants to get serious about data science or machine learning.
It really is.
And speaking of prerequisites, it's probably a good time to touch on some common NumPy questions that might trip people up in, say, data science interview.
Oh, yeah, interviews. That's a good point.
What are some of those questions, and what are some things that might catch people off guard?
Well, one question that often throws people off is the difference between np.array and np.sArray.
Oh, yeah, I've seen that one before. Always get them mixed up.
They both create NumPy arrays, but np.sArray is more flexible with its input. Say you're working with data that might already be a NumPy array or might just be a regular Python list. np.sArray can handle both without any complaints.
Oh, that's good to know. So it's like np.sre just takes whatever you throw at it and says, we'll figure it out.
Pretty much. Another tricky area is structured arrays.
Structured arrays.
Yeah, they allow you to work with data that has different data types, combining numbers and text in a single array. It can get a little confusing at first.
Oh, I bet. So structured arrays definitely one to brush up on before an interview.
For sure.
So we've covered a lot of ground here. We talked about why NumPy is such a big deal in data science, how it handles data so efficiently, and even touched on some tricky interview questions. What would you say is the key takeaway here for our listener?
I think the key takeaway is that NumPy is more than just a library. It's like this foundational tool that underpins a huge ecosystem of data science tools and techniques.
Right, it's like the foundation on which everything else is built.
Exactly.
Mm.
And understanding NumPy not only allows you to analyze data effectively, but also opens the door to so many other things. Machine learning, image processing, you name it. It's really empowering.
That's a great way to put it, empowering. And as a final thought, if NumPy can handle all this numerical data so efficiently, it makes you wonder what other areas beyond like the traditional data science realm could benefit from its capabilities.
Yeah.
Right? That's something to ponder, something to explore further.
Definitely something to think about.
All right, everyone, thanks for joining us on this deep dive into NumPy. We hope you learned something new, and we'll see you next time.
See you next time.